Hi guys, welcome to episode 11 of Tiger Heart Chats. I have got one of the coolest guys around, and when I say cool, he is straight from the polar ice caps. Please welcome to the stage a fantastic technologist and engineer, Mr. Robert Edwards.
Hi there.
Hi Robert, how you doing?
Very well, very well. Yes, in these strange times of viruses and lockdowns, we're still moving forward. So something to be very grateful for.
Brilliant. Jasmine Predicito, who runs a fantastic art community, introduced you and I and told me that you would be really good on this call. So I'm really excited. There's people that are listening to this podcast who don't know much about you. Tell us who you are and what you're about.
Oh, I'm Robert Edwards, or Eddie Edwards, as I was known in my nicknames in my early years of my career. That was before the famous ski jumper came and stole the name away from me. I started my life working in the theatre. I left school before the exams really kicked off and stuff like that, because I'd fallen in love with working in the theatre. So I started doing that for many years, and then I moved over into the sort of events world of concerts and sporting events and things like that. So I did that up until my sort of early 30s, when I got involved in designing touring systems. So how can you move equipment around the world, put it up for an event for a day, take it down again, move it on. And I started doing more of that. And I really wasn't taken very seriously by the people designing the equipment, because I had no qualifications. I just had a lot of experience of moving equipment around the world and setting it up and taking it down again. Right. So, and I had one of those sort of times in my life where I wondered what I was doing and and I went to a careers advice centre who said design engineering was the way for me. And so within a few weeks, I found myself at university. So I was at South Bank learning how to be a design engineer or a product design engineer. And it was then that sort of my dyslexia was diagnosed, and I got some help, and I graduated from there, and I went on to do a master's degree and then a PhD. But during that time, I started work for Solar Century, who were based in Waterloo, and started helping design their solar rooftile system. And this was whilst I was a student. I just did a couple of days a week with them. And that's what sort of started me down the route of interest in solar, renewable energy, that sort of thing. And whilst I was at Solar Century, Bill McDonough came to the office, and I'd never really heard of Bill before. And he just stood up and gave a 10-minute talk about cradle to cradle design. And this was back in the very early 2000s. I was just really taken with how sort of passionate he was about how design could really help the planet. So you're designing products for reuse at the end of their life, but not just for recycling. So you take something that's very valuable, you grind it up and you make it into a road covering. No, you design the product so it makes a product of better or greater value than the original product. And I was really taken with this, and I managed to persuade the DTI at the time to fund me to go and spend 6 months with Bill in his offices in Virginia, and to work on solar products. So I would sort of give solar advice to his team of architects, and in return I would learn about the cradle to cradle design philosophy and stuff. And I had some amazing experiences there working. At one point I had a very nervous presentation where we presented to NASA and I had to present solar power to NASA, who had invented it. So it was, but I met some amazing people, and I'm still very much in contact with them. Some of the architects from there are now working with the Make It Right project in New Orleans, still rebuilding with sustainable buildings there. And during the time of designing the solar rooftile system, that's when I started to become aware of the power of solar thermal, how much heat and how much energy you could actually get from the sun. And I went to a conference or a sales thing about computer-aided design, and at the coffee break, I was having a coffee and introduced myself to the guy who was sitting next to me. And this was Michael Reed. And I said, well, I design solar collectors. And he said, I design refrigeration systems. So this was 11, 12 years ago now. And I sort of went, well, do you know how much heat these things produce? And we started to work together to look at solar cooling.
Wow. So that's what's kind of leading us into solar polar, am I right?
It is, yes, yeah. That's where it started, and we would meet up once a month, and we would review patents, academic papers, and all these things, because solar cooling was patented, like 100 years ago. I mean, people were thinking about how could you do solar cooling and stuff like that.
So tell us about solar polar.
Well, solar polar is generating cooling from the sun, but we only use solar thermal. We don't use any electricity. So to take it back a step, there are two forms of solar panels. There's the photovoltaic or PV panels, which convert the sun's light into electricity, and you'll have seen the flat sort of panels on the roofs. And then you have solar thermal, which look like long tubes, or again, they can be flat panels, and you take the heat of the sun and you heat your hot water with it. So we were looking at, as I say, the patents go back a long time, and a lot of people have thought of this, and we looked at all of the ideas that had come before and had gone, and where we thought people had made the mistake in the past with these solar cooling systems was engineers being engineers, is they try to make the most efficient system you possibly can. And when you strive for great efficiency, you make things very expensive.
Right.
And so it's a bit like, if you need to know the time, do you need a Rolex watch or do you need a Casio watch? If all you need to know is the time, then a Casio watch will do the same thing, a $5 watch as opposed to a $5,000 watch. So we took the step back and we said, well, actually, because you're not paying for the energy source, the efficiency doesn't matter because the fuel is free. What matters is how much does it cost to convert that sunshine into a watt of cooling? So sort of a pounds or dollars per watt of cooling is the metric you need to work for, because if people are going to adopt renewable energy technology, what they really want to know is, if I switch over to this system and I save on my electricity bill, how long does that saving have to go on before it pays for itself, and then I'm sort of in profit? So if you said to somebody, oh, if you fit these solar panels to your house, it'll be a 150-year payback period, people would be thinking, well, no, whereas you say, well, actually, after 2 or 3 years, the thing will have paid for itself in the electricity saving, and then for the next 20 or 30 years that you have the system, you're getting that for free. So you're put in kind of thing.
So you basically had a different approach to a methodology that was kind of thinking in I don't want to say the wrong way, because obviously it's kind of been enlightening to the people that were involved in it, but you basically took the approach and just applied a different methodology to that approach.
Yes, because what people... I just don't want to be rude about other engineers and things, but when you look at air conditioning or refrigeration and you say, well, actually, I want to make it solar, they say, well, so we take away the electricity and we replace that with solar electric panels and batteries. And so all I've done is I've kept the original refrigerator or air conditioning system, and I've replaced the method of making the electricity. Whereas we took a step back and said, well, actually, photovoltaic panels are brilliant because they create electricity. And electricity is incredibly valuable, especially sort of in the developing world where you need to charge a mobile phone, you need to charge a battery light. There's a lot of very, very useful things that electricity is incredibly valuable for. When you start to move on to things like refrigeration, air conditioning, that's incredibly energy intensive, just in the nature of trying to cool things down. So actually, if you do that thermally, it's a better way. It's not as efficient as doing it with electricity, but the equipment you need to do it is an awful lot cheaper. Solar thermal is sort of an order of magnitude cheaper than photovoltaics. So we're not saying, oh, don't have photovoltaics. No, photovoltaics are brilliant, and they should do the bit they're really good at, which is the electricity side, and everybody needs electricity, but don't waste that precious electricity doing something like running a refrigerator, which you can do with heat.
So my assumption is solar polar, you focus on the solar thermal physics.
Yes.
How does solar thermal work?
Oh, now this is an incredible. I mean, it's the way the cooling systems work and the thermal side of things. It took me probably working with the system a year to 18 months to understand it enough to be able to hand on heart, be able to point to all the parts and tell you exactly what they did.
It's quite a crazy question, but I guess what I'm trying to understand, I'm sure there's a lot of people listening, my assumption is you're working with a different type of mindset when it comes to the benefits of solar energy. What are the benefits of solar thermal? Where does solar polar fit into that? What is it that you guys do using the physics of solar thermal?
Okay, right. Well, solar thermal has the advantage of you're producing heat, but it can be done very efficiently using solar thermal. So a thermal transfer can be 70, 80, 90% efficient, whereas when you're converting sunlight to electricity, it can be 10, 15% efficient. I mean, there are more efficient ones in the laboratory, but your average one is probably about 12%. So the conversion of the amount of energy that you can turn into something useful using a thermal system is much higher. The temperatures we like to run at are higher than hot water temperatures. So we've modified the solar thermal system to run at a much higher temperature. So that's one of the ways that we've modified a solar thermal system. But what we're doing is we are boiling ammonia out of water. And this is a very old technology. This does go back. This is the same technology you use in minibar refrigerators. And so you're effectively using the heat to boil ammonia out of water. Right. You're condensing the ammonia into a liquid. You're then evaporating that liquid, and that evaporation is what absorbs the heat from the room that you're trying to, or the area that you're trying to cool down. In the same way as if you put that alcohol wipes or something, or on alcohol on your skin, when it evaporates, your skin feels cool. So that's what's happening, is it's actually drawing the heat out. So that's what's happening. And once you've had the evaporation, you then need to turn that back into a liquid, and round the system it goes again.
Wow.
So I've incredibly simplified.
No, of course. And there's just a lot of people listening that would just want to try to calculate what that means in their minds. I really appreciate and value And I'm sure the people listening really appreciate and value you simplifying that.
We do have some, if people are interested, we do have infographics, which our good friends at the Design Laboratory did for us to kind of try and simplify the process to show people, and even to us, even as we explain it to somebody who creates graphics, it becomes stronger in our mind how the system works and how to explain it and things like that. So
absolutely. How long has Solar Polar been running for?
Well, I met Michael, as I say, 11, 12 years ago now, and that's when we started talking about it. But back in 2015-ish, we had filed a patent on the system, and that was granted. And we started to get some interest from Innovate UK and the government to start building some prototype and some demonstration units. So from 2015, 16, that sort of time, and that was the point where we were starting to get some traction. I had a full-time job. I was working for the government as part of the Chief Scientific Advisors team, advising the government on renewable energy. And I thought, well, actually, we really need to commit fully. So I quit my job and went and became sort of the first full-time employee of Solar Polar. And it's been going on since then.
Amazing. So how many products have you launched since then?
We're still working on the first system at the moment. It's a modular cooling system. So you have a module that produces 200 watts of cooling, and you join those modules together to match your cooling load. So, one or two of them would run a refrigerator, and 6 to 10 of them would cool a 40-foot shipping container, and 15 to 20 of them would cool a well-insulated house. So it's the same module. So we have 6 modules in India on demonstration. They've been out in the India sun for nearly 2 years now.
Whereabouts in India?
In Ahmedabad.
Okay.
We have a great company out there who have partnered with us, Hyperion and Mamata. They're both out there, and they've been looking after the system which sits outside their factory. We have 4 modules in Florida with a company called Arctic Solar, and they produce a concentrated solar system that we've been trialing with our system that's working very well. As I mentioned, we got some Innovate UK grants, so we will be going out to Kenya later this year with a refrigerator and a refrigerated container, 20-foot container, to Kenya. So we'll have 2 on farm in Kenya, and we won one of the finalists in the Engineers Without Borders Chill Challenge. So we'll be taking one of our systems to Egypt to start making ice from the sunshine there. So
that's cool.
Literally, yes.
Yeah. Just with regards to the business, it's still in its infancy. You're starting to make ground, and the idea is, as the notion of the way you apply the physics of solar energy in a new way, you're hoping to excite the market and then start to mass produce products that you can sell on a commercial level.
Yes, yeah, I think we're in what they affectionately call the Valley of Death. which is the point where you've done the product development work, you've got the demonstrators, and you just need to get from there into manufacturing and selling the units. So once you're manufacturing a small number and selling, it's very easy to get investment to kind of because people can look at it and they say, oh, well, you're making 100 widgets and selling them for this much. So if I made a factory that made 100,000 widgets, we'd make this much. So it's that sort of, how do you get yourself from having a small number that you hand make to manufacturing? But we seem to be getting there. We're making sort of slow but steady progress.
I mean, it takes time, and I love that type of mindset where you look at something and wonder why it's not working. And the reason why it's not working is because of how it's been applied to the current situation. Prime example, I was looking into some of the research that's going into how do we propel people into space in a way that's different to the current burning of fuel model. How do we look at those physics and manipulate those physics? I get really excited about the way lots of businesses are starting to disrupt old mindsets. And it sounds like you guys are really doing that with regards to solar energy. And that's amazing.
Well, we should probably talk offline, because we do have a method of launching things into space that doesn't use a great deal of fuel, should I say?
That's fine. Well, that's another podcast. That's another podcast.
We could talk about that another time. But yes, that's one of those. That's one of those things that myself and my colleague Michael. It's the kind of thing that we go, oh, couldn't we do? Have we tried this? Oh, what about? Or you see a new product, or you see a new material, and you start to look at it and you think, well, what are the possibilities? And that's why it's lovely working. I'm a visiting academic at Imperial, and I supervise a PhD student. But it's great to work in that environment, because you get to meet other students and researchers and see what these guys are developing, because there's row after row of little laboratory rooms, and there's people just doing incredible stuff in there. And sometimes it takes the person who looks round the corner and looks at what you're doing, because you're developing something for, I don't know, this is the wonder of research, is you're developing or trying to solve a problem, but inadvertently you've solved a completely different problem, or it could be applicable to a different industry.
Well, I think we're going through a golden era of divergent thinking at the moment. So I've just finished my GSX2 at Harvard in Leaders of Learning. The course kind of focuses on how the learning traditionally is structured in a way that was built during the Industrial Revolution, and how there's so many great things about that. But right now in our current era, the way people are learning needs to change. I think that applies to lots of things, and it's one of the reasons why someone like Elon Musk is starting to create prominence within industries that were traditionally going in one direction, because he and his companies are disrupting those little industries, whether it's how people pay for things, or SpaceX, or Tesla. And it's just great to find another business that's doing that, that's really trying to disrupt what the standard direction is when you're trying to think about something. And it's amazing.
Well, I would entirely agree with you on the schooling thing of just sitting people down and telling them to memorize stuff and then regurgitate it again in an exam. And to me, as I say, I left school and I had no qualifications. I slipped behind in the schooling process. I couldn't quite cope with it. And I left school convinced I was stupid and I would never achieve anything. And as I say, I went and I fell in love with working in the theatre, and I did lighting and sound, and it was great. And I did very well in that. And I thought, well, that's not supposed to happen, because I haven't got so many O levels or A levels or. And it wasn't until later on when I went to, as I say, I went to South Bank, and I turned up there and said, well, I haven't got any qualifications, but I'd like to do a degree. And the lovely guy, Chris Dowland, who I think is subsequently retired now, he just said to me, he said, well, you've got some great experience. He said, I'll tell you what, he said, we'll let you in. And if you pass your exams at the end of the first year, you're in. And if you don't, well, we'll just go our separate ways, sort of thing.
Wow.
And
That's brilliant.
And it's fantastic. As I say, they kind of diagnosed my dyslexia, and, I went through, I came out, I graduated. And as I say, I went on to do a PhD at Imperial. So, and awesome. This was a product of somebody who came out of the schooling system thinking, that he was stupid and wasn't really capable of anything.
Oh, well, it's great to hear that, you've overcome that. Let's talk about some of your past then. So it's quite interesting. You mentioned that you started in the arts sector. Now, I find that interesting because myself, I run a tech company, Tiger Heart. We work with brands to help them explore their narratives using emerging technology. And what I found within the tech space is there's lots of us who started within the art. I started as a musician originally and studied music at university. But there's lots of these people who have come from the art space and gone into the tech space. Tell us about your artistic background and how that's kind of shaped your journey into this current technological revolution that you're part of at the moment.
Right. Well, as I say, I went to my local civic centre and started working there, and I would just turn up every day. It wasn't really a proper job for me at the time until. So I would just work and show movies and work on the local amateur dramatics stuff. And my boss at the time my boss at the time sort of recommended me. And by the time I was 16 or 17, I was working as an electrician in the Garrick and Wyndham's Albury Theatre around Charing Cross Road there.
Right.
And just working with the most amazing people, these incredible sort of flamboyant, outrageous characters. I mean, I've never had any great desire to be on the stage or in the spotlight, or I'm kind of rather an introverted person who, I had no, but I loved being around those people. And I think the thing that I really took away from it, because I then went on to work with the big video screens that you see at the side of the stages, and did shows with a lot of the big bands and things. But the thing you really take away from it is that the show must go on. And you have to get the job done. You can't just turn round to an audience of people and sort of say, "Oh, we're not ready yet." Or, this bit's broken, so you'll all have to go home and not see the show. So that was one of or probably the biggest thing I took is the dedication of the people who are putting on the shows, from the costumes and the front of house people and all, everybody is kind of working. And it's an amazing environment to work in, because although you're working every evening, you're also involved very much in everybody's night out. If that makes sense. You're in a building that's full of 400 or 500 people, all come for an evening out, or come to watch a band, or come to watch athletes, or whatever it happens to be. But it does involve an awful lot of time away, and it is a huge commitment because your social life then becomes very, very much the people you work with. So you go out after work and blah, blah. So it does become very all-consuming. But just that, but I just love that sort of style of thinking, the people who want to create a visual spectacle and things, and that's why it's lovely working with Jasmine. I'm doing the rather boring kind of metal sculpture structures that hold the sculpture up, or helping out with helping with the lighting, or getting people to help with the lighting and stuff like that. But it's I think somebody said, without the arts, this lockdown would be just awful if you didn't have television programs and live streaming of theatre events and galleries that you can see, even if it's virtually, and things like that.
Absolutely. Artistic endeavours lubricate society.
Absolutely, yes, yeah.
So you did that for a long time. You touched on your dyslexia when you started to study at South Bank. And I've heard a crazy statistic. I think it's something like 1 in 6 people has dyslexia or something like that, and they don't know it, or some form of dyslexia. Talk to us about your experience of that being diagnosed and just what your thought process was during that period.
Well, it was, I had noticed that I was slower at things like, for example, if you were sitting down to a lecture and they would give you a handout and they would say, read this before I start the lecture, that I would still be reading it long after everybody else has read it and is looking around and chatting to other people, sort of thing. My spelling had always been awful. I mean, dreadful. And that's how my entire school career was, in my mind, is branded as being the guy who couldn't spell. And it was during, as I say, the second year of my degree, there was a poster that went up and just said, have you got trouble spelling? Are you slow at this? Are you da-da? And I went down the list and bless the South Bank, they laid on the full assessment procedure. And they came back and went, oh, yeah, you've got this problem, short-term memory problems. And they were talking about having memory problems from the time of reading it on the whiteboard to looking down onto the piece of paper and writing it down. That kind of short-term memory problems. But the thing that's sort of lovely now, I mean, there's lots of software that can help with your spelling and things like that. And also I found that because we now all communicate via email and text and things like that, just by the nature of the very repetitive nature of constantly typing out words, you do sort of learn the spelling of them. But the thing that I wish I'd known back then that I know now is my brain is far more, I don't know, what's the word for it? Is it 3-dimensionally aware? If that's the right expression, that when I'm designing something, I can see it in 3 dimensions in my mind. I know how it fits together. I know where the parts go. So when I translate that into a CAD system for a fabricator to make, I'm just seeing on the screen what is already in my mind.
Yeah.
And what I didn't realise is that's not the same for everyone. So,
yeah.
I just assumed that there was something wrong with me, and because I couldn't spell, and spelling seemed to be some kind of metric in the education world as to how smart or how far you were going to go in life, seemed to be held up as a stop. So I realised that dyslexic people have a different way of viewing the world, but their spatial awareness seems to be better than most, or different to most, should I say.
Yeah. One thing that I did learn from studying this Leaders of Learning course is that the learning system at the moment, that there is an assumption that it's built for everyone, but the reality is it's kind of built for some people. And that kind of understanding that people's perspectives and also how people perceive things is different for everyone, whether they're dyslexic or not, whether they're good at certain things or they're bad at other things, and everything in between. And that's the beauty of us as human beings, is that we are a myriad of fantastic things, and all of them stem from chemical imbalances or light or sound or color or whatever it is,
But there are two things in what you've just said that I'm kind of really anxious to respond to. Firstly, that sort of, I think part of the problem with the education is the continual testing, and the government using that to work out how well things are going, rather than just trusting teachers to teach kids what they need to know. They seem to have them doing tests all the time so they can grade them against, their performance. And so I think the education system is in the danger of, or if not has just become, let's teach them how to pass the tests, and then we get the tick in the box, and then we get the money to make it a bigger school, or we don't get so many inspections. And obviously that doesn't play to the strengths of the people who aren't very good at taking tests.
Absolutely.
But you mentioned the brain, and one of the things that I find most amazing about my brain, and this is a lesson I took from a dear friend of mine, Corey, who, I mean, he's designed some amazing things for Apple. And he said, oh, no, he said, the way I solve a problem is I concentrate on it. I concentrate, and I can't remember how many seconds, but it was only sort of 20 or 30 seconds. He said, I completely try and wipe my mind and I focus on this thing, and then I forget about it. And then he said, within a few days, the answer to the problem will pop into my brain. And I thought, oh, that sounds a bit strange. But then I realized just how many times when you've been trying to think of a problem or a solution or a new idea, and you've been thinking around it, and you'll be in the shower, and all of a sudden, from nowhere, into your mind pops this. You kind of go, oh, why didn't I think of that before? Or that's a great idea, and I can't wait to tell. So I don't know whether it's the white noise at the shower or that sort of thing, but your brain does have this amazing ability to be able to take an idea away whilst you're getting on with the rest of your life,
yeah.
And then suddenly pop back later and go, oh, what about this as an idea? So
you've actually grown into being someone that's starting to disrupt the way people think about things, and you're starting to design and build the future for some people. You've won a few awards for your design engineering. Tell us about those awards.
Well, if I go right back to when I was doing my first degree, and you get your final year design project, and I was thinking about what do you make, and I thought, well, actually, you might as well make something crazy, because the likelihood is you will leave here, get a job as a designer, and you will be designing widgets in a factory somewhere, and you won't have a lot of say over what you design. So I designed the hoverboard.
Wow. And when you say the hoverboard, which hoverboard was that?
It was somewhat inspired by the Back to the Future movie. And also I skateboarded when I was a kid, and obviously living around the South Bank, I'd seen them skateboarding, and I kind of realized that, well, you could only really skateboard on flat concrete surfaces. You can't go off road, you can't go across the grass, you can't go on water, all that sort of thing. So I thought, well, what happens if you actually made a small hovercraft? So that was my final year design project, and I actually managed to make a small hovercraft that you could float around on.
Wow. Have you still got it?
Yes, actually, it resides in the shed.
I have to come over and test it out. Back to the Future 2 is one of the best films I saw in the cinema as a kid.
Excellent. Well, it does inspire a lot. But when I came out of university and was looking for something to do, I applied for the Audi Design Awards, and I won that, and they paid for me to make a new prototype version, which was battery powered. So I was probably, back in the very early 2000s, one of the first people. Well, I think I'm the only person to have made an electric hovercraft. So using lithium ion batteries from Saft in France, and
wow.
This was at a time when I think there weren't very many of them about. So when you ordered them, you kind of had your name written on them in the factory, because they were so yeah. So I built one of the first electric lithium ion powered vehicles. So that was a lot of fun, and it was a company for a while. And I tried to get funding and to get it into mass production and stuff like that. But I was very new to new to the world of setting up your own business in those days. But it is something that I'm going to go back and revisit when I have the time, because it did come to the point where I was looking at hoverboard and solar polar, and I had to really make a decision as to, I've got to focus on one of these. And so I parked the hoverboard. But the nice thing is now I'm looking at the drone technology, the auto leveling and stabilization, and battery technologies. There's a lot more of it about. In those days, as I say, we were using some of the very first lithium ion batteries from Saft and stuff. So
wow.
It will be interesting to see what we can use. This is once we've got solar cooling out into the market, we can go and revisit that. So that was my first sort of design award. When I was at Solar Century, we developed the C21 T&E, which was a solar roof tile, and it could either have a photovoltaic solar electric panel in it, or it could have a thermal panel in it. And that won a number of design awards and building awards. And since then, Solar Polar, we've won the Rushlight Awards. I mean, this isn't all me, of course. This is lots of other people involved as well. But yeah, so we won the Rushlight Awards. We've had a number of awards from the government for development and R&D and stuff like that, which is a big sort of tick in the box for sort of due diligence, because their technical people check out what it is you're trying to do and say, well, actually, these guys are onto something here. Let's try and support them. So
amazing. Amazing. And then just with regards to the stuff that you're doing with Solar Polar, have you guys won any awards yet?
So I mentioned the Rushlight Awards. We won one year, and then we were commended the following year. I'm trying to remember. I think we won something from the Cambridge. Oh, I should really have a list of these, shouldn't I? So, apologies to people who've given us awards. But yeah, so we've had the Cambridge Clean Tech guys. I think we won something with them, which we got a lot of business support and things like that. So it's not always sort of a shiny plaque or an award, but sometimes it's just having an accountant come and help you develop a business model, a financial business model, looking at your cash flow going forward and stuff like that, which is it's not as good. Well, it's very, very useful to you as a business. So.
You're still in your infancy as a business, so I'm sure there's lots more to come. We're kind of coming towards the end of the podcast. And before we go in with the outros, I just want to ask you one question. And I thought I'd allow a bit of extra time for this because I'm sure there's a lot to talk about. What is cradle to cradle design?
Cradle to cradle it's about designing things so that they can be reused at the end of their life, not just recycled. Apologies, I think I touched on this a little bit earlier.
You did, yeah.
But it's about designing things so that when they are reused at the end of their life, they are for an equal or better product. So you don't take something and melt it down and make it into so if you've got a computer, you don't melt down the component parts and make them into a building block or something like that. You take them and you make a circuit board or a better circuit board or something like that. And it's not just the product side about it. To become cradle to cradle certified, you have to, where does your energy come from? Where does the water come from and go to when you finish making stuff? How well do you treat your employees? And you can't on your own be cradle to cradle. It's about your supply chain as well. So
right.
if you're buying nuts and bolts from the guys down the street, where do they get their energy from? Where do they get their water from? How well do they treat their staff? And things like this. So it goes through. So to be at the top level of certification, there's an awful lot of work to do. Cradle to Cradle, I guess, sort of became circular economy. Ellen MacArthur's driving it sort of forward in the UK. And I know she's working with Bill McDonough and the other Michael Brogarden. I think he was the German collaborator on a sort of European side. I hope I got his name right. Circular economy is kind of pushing people in the right direction of reusing things at the end of their life. The cradle to cradle process was far more involved. As I say, it went right down the supply chain. And if you used something in a product that was bad for the environment, it was on a traffic light system. So if you had a red light somewhere in the supply chain, then you couldn't be cradle to cradle. And there's a number of companies, and it's a design philosophy as well. It's a bit like if you're building something, don't glue the things together, nut and bolt them together, because if you've glued two different products together, you can't recycle them. Yeah. If you can unbolt them, then you've got the two separate materials that you can reuse. The office chair world really sort of embraced this. There's a lot of cradle to cradle designs. There's a company called Desso Carpets, used to be run by our company chairman, Steph. Desso, when they took it over, when Steph and his colleagues took it over, made carpet tiles, and Steph embraced the cradle to cradle. So I think they have the first system where you send the carpet tiles back and they can break them down into their component parts, respin the yarns, and they make carpet tiles again from it. So you get Brilliant. New ones out. And but that was Steph Cranendike basically driving that forward and saying, because when you look at building a building and the energy it takes to build a building, you think, well, what is it that uses the most energy? And you think, well, concrete, that must actually take, an awful, and it does take a lot of energy to make. But actually the thing that takes the most energy to make is the carpet. Right. And if the carpet's got a rubber backing to it, it's even worse. So the amount of energy it takes to actually physically make it, it's one of those strange things. But as I say, Desso will come along, they take the old carpet tiles away, they put them through the factory, and they come out as raw materials that they then use to make new carpet tiles. So it's
awesome. So it's basically like a future-proofing methodology so that all the components that you're using can be reused in an efficient way.
Yes, yeah. I mean, because at the moment we seem to have gone through decades of just buying stuff in and throwing it away. I think in the States, I'm trying to remember back now. It's a little while since I've looked at this, but it was something like of the stuff that comes from China to America. Within a few months, a huge percentage of it is in landfill.
Yeah.
And we have this sort of great throwaway society, and packaging on food and things. And I would love to be able to say I could think of a solution for packaging on fast food or something. I need to focus, but yeah, I mean, and we do need to address that.
Absolutely. Just the last question I wanted to ask you. So just going back to that cradle to cradle methodology, how have you applied that into what Solar Polar does?
Well, we haven't started the certification process because we're not actually mass producing them yet, but everything has been designed with that in mind. Right. So the cooling system itself, I would say probably 90% of it is mild steel. So that is all very recyclable. It does have an incredibly long life. I mean, once the solar cooling modules start working, they've got a 30 to 50 year life in them, so there's no moving parts or anything, so there's very little to go wrong with them. But yeah, so the steel work, that can all be recycled. The glass from the solar tubes can, the copper pipes from the heat pipes. So there's not very much in there. The ammonia water, although ammonia is very smelly, it is actually a natural refrigerant, so we don't have any greenhouse gases. So I'm fairly confident that the way we've designed it and the way we've put it together, actually doing the certification process for Cradle to Cradle should be fairly straightforward.
Amazing. Robert, I just want to say this call has been a fantastic, eye-opening and interesting conversation. I really appreciate your time. I'm sure everyone listening will get loads of value from it. If there's anyone that wants to get in contact with you, what's the best way to do that?
You can email me. That's normally the best way. That's r.edwards@solar-polar.co.uk. So yeah, drop me an email, have a look at the Solar Polar website, and I'd be happy to share any information on anything I've been talking about.
Seriously.
Okay, I'd be happy to make introductions if people are interested in the world of Cradle to Cradle and stuff like that.
Yeah.
I'm happy to sort of share and collaborate. Or thank you for the opportunity just to.
It's been fascinating. Seriously, thank you so much for your time.
Not often you get to that long to talk about yourself. No, thank you.
Awesome. No worries. For you guys listening, wherever you are, I hope you're having a good time and I hope you're safe. If you really enjoyed this podcast, please do subscribe. And if you're sharing anything with regards to the podcast, please use the hashtag Tiger Heart Chats, all one word. Wherever you are, whatever you're doing, I hope you're safe and please be good.